Welcome back to Java Internals Crashcasts. I'm Sheila, and today we're continuing our journey through the Concurrent Collections season. We're in the Maps and Sets chapter, and we've already covered the Concurrent Map interface and Concurrent Hash Map. Today we're diving into ConcurrentSkipListMap. Victor, are you ready to explore this fascinating data structure?
Absolutely, Sheila. I'm excited to unpack ConcurrentSkipListMap for our listeners. It's a unique and powerful tool in Java's concurrent collection arsenal.
Great. Before we jump in, let's start with a quick quiz for our listeners. Here's the question. In a skip list data structure, what's the average time complexity for search, insertion, and deletion operations? Is it ON, O log n, or O1? Think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It really gets to the heart of why skip lists, and by extension ConcurrentSkipListMap, are so interesting. Without giving away the answer, I think our listeners will be surprised by how efficient this data structure can be.
I agree, Victor. Now, let's start with the basics. What exactly is a skip list, and how does it relate to ConcurrentSkipListMap?
Great question, Sheila. A skip list is a clever way to organize data that allows for fast searching within an ordered sequence of elements. It's like a series of linked lists stacked on top of each other, with each level skipping over more elements than the one below it. Imagine it as an elevator system in a tall building. The ground floor has stops at every room. The next floor up stops at every 10th room, the next at every 100th room, and so on. This allows you to quickly get close to your destination before taking smaller steps.
That's a helpful analogy, Victor. So, ConcurrentSkipListMap is an implementation of this skip list structure that also happens to be thread-safe, right?
Exactly, Sheila. ConcurrentSkipListMap is Java's concurrent implementation of a sorted map based on a skip list. It provides expected average log-n time cost for contains key, get, put, and remove operations and their variants.
That's interesting. How does it compare to Concurrent Hash Map, which we discussed in our previous episode?
Great question. While both are thread-safe map implementations, they have some key differences. Concurrent Hash Map is based on a hash table and doesn't maintain any order of its keys. ConcurrentSkipListMap, on the other hand, keeps its keys sorted, which can be very useful in certain scenarios. Also, ConcurrentSkipListMap generally has log-n performance for most operations, while Concurrent Hash Map aims for constant time but can slow down in worst-case scenarios, like when many elements end up in the same bucket.
I see. So if we need a sorted thread-safe map, ConcurrentSkipListMap would be the way to go. But how does it achieve thread safety? Does it use locks like some other concurrent collections?
Actually, Sheila, that's one of the most interesting aspects of ConcurrentSkipListMap. It uses a lock-free algorithm for its implementation. This means it doesn't use traditional locks to achieve thread safety. Instead, it uses atomic operations and a clever algorithm to ensure that multiple threads can safely modify the structure concurrently.
Wow, that sounds complex. Can you break down how this lock-free algorithm works?
Certainly. At a high level, the lock-free algorithm works by using atomic compare and swap operations. When a thread wants to modify the skip list, it first creates a copy of the relevant parts of the structure. It then makes its changes to this copy. Finally, it tries to replace the old structure with the new one. If another thread has made changes in the meantime, the operation will fail, and the thread will simply try again with the updated structure. This approach ensures that updates are always consistent, and that no thread can interrupt another mid-operation.
That's fascinating, Victor. It sounds like it could be very efficient in highly concurrent environments. Are there any particular use cases where ConcurrentSkipListMap really shines?
Absolutely, Sheila. ConcurrentSkipListMap is particularly useful in scenarios where you need a sorted, thread-safe map and have a lot of concurrent read and write operations. Some common use cases include 1. Implementing priority queues or task schedulers, where tasks need to be sorted by priority or execution time. 2. Managing leaderboards or scoreboards in gaming applications, where scores need to be kept sorted. 3. In financial applications for order books, where orders need to be sorted by price and quickly accessed. In these scenarios, the ability to maintain sorted order while allowing concurrent access can be a huge advantage.
Those are great examples, Victor. Now, I'm curious about potential pitfalls. Are there any common mistakes developers make when using ConcurrentSkipListMap?
Good question, Sheila. One common mistake is assuming that because it's concurrent, all operations on ConcurrentSkipListMap are automatically atomic. While individual methods are thread-safe, combinations of methods may not be. For example, the common check-then-act pattern, like checking if a key exists and then adding it if it doesn't, isn't atomic unless you use the put-if-absent method. Another pitfall is overuse. While ConcurrentSkipListMap is powerful, it does have higher memory overhead than some other map implementations due to its skip list structure. If you don't need the sorting or high concurrency, a simpler implementation might be more appropriate.
Those are important points to keep in mind, Victor. As we wrap up, could you share a quick tip or best practice for using ConcurrentSkipListMap effectively?
Certainly, Sheila. One key tip is to use the navigable map methods that ConcurrentSkipListMap provides. Methods like ceiling key, floor key, head map, and tail map can be very efficient ways to work with ranges of sorted keys. These operations leverage the skip list structure and can be much faster than manually iterating through the map.
That's a great tip, Victor. Now let's get back to our quiz question. We asked about the average time complexity for search, insertion, and deletion operations in a skip list. Victor, would you like to reveal the answer?
Of course, the answer is O, log n. This logarithmic time complexity is what makes skip lists, and by extension, ConcurrentSkipListMap, so efficient for large datasets. It's able to achieve this by using its multi-level structure to skip over many elements in a single bound, much like our elevator analogy from earlier.
Thank you, Victor. That wraps up our discussion on ConcurrentSkipListMap. In our next episode, we'll be covering ConcurrentSkipListSet, another interesting concurrent collection. Listeners, if you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue producing these in-depth explorations of Java's internals. Until next time, happy coding.